I wanted to give you a sense of what we're doing this time around. So every first Friday of the month, we try to bring science, technology, engineering, and math closer to you to give you more experience with it, more exposure. I've been told to have at least one last-minute registration, but I suspect I'm related to that person. So hold on just a second, I'll fix that while I'm doing this at the same time. So we try to bring this stuff to you, and you know, we've had people come in the past to talk about a variety of different things. We're doing that as well. So we're talking about some new research, we're talking about specifically climate change, but we're also in the middle of what we're calling our celebration of women in STEM. Right now, we started that in July, where we were posting about a wide variety of amazing women who are doing some really, really cool things in their fields. And so we are continuing it. We're doing virtual educator-led activities. So we did one last weekend that was about paleoecology and kind of simulated how paleoecologists do their work. We've got others planned for the end of this month and then again in September. So over July, August, and September, with the help of a grant we received through the If Then program and the Leidy Foundation, we're working to highlight women in STEM to show, first of all, the variety of things that women are doing, but also talk a little bit about their journeys and how it became accessible to them. So this is going to be a kind of a combo of that. I'm definitely talking about my research that I've done, but I'll be throwing in some anecdotes as well and some information on the process in terms of how we make some of these decisions, where some of these questions come from, what happens when stuff goes really wrong, those kinds of things. So it's going to be, you know, a bit more of a broader, perhaps, perspective on some of this stuff, but hopefully just as informative. I mean, this stuff is near and dear to my heart. I've spent an awful lot of time in boats and stuck in the mud and things like that in order to learn the things that, also stuck in front of my computer, in order to learn the things that I'll be talking about today. So I hope you find it interesting. It is a little different in the sense that I'm not talking about New Hampshire, I'm not talking about New England, I am talking about Louisiana. And if you look right behind me, this is a picture of, I mean, technically we could call it an island. I think it's bigger now because they've been doing some restoration work on it, but it's called Queen Bess. And it's basically, or at least was when I was doing my research, now they've added some sand. It was a ring of rocks with a bunch of water in the middle. And as you can see, wildlife loved it. They thought it was so great. And that's a brown pelican flying over my head. There's a ton more in the water. There's all sorts of birds on this island, also other creatures too. And this is a good example of my study sites. Lots of water and mud, shrubs that you have to like fight your way through, and then birds that will poop on you all the time. Like that's pretty much my experience. But this gives you an idea, I think, of what it was like out there. And hopefully as I talk about my research, you'll have an idea of how we created it and what we're using that information for. So what I'm going to do, just so that I can see it when I'm on this screen, is I'm bringing up the chat box just so that I'll know. The way that we'll do this is once I start sharing my screen with my actual presentation, that's what I'll be focused on. And so Faith will be checking things. And Faith is our education coordinator. So she'll be checking in, and then occasionally I will say, as I'm talking about something, are there any questions? She'll let me know if there's anything that anyone's brought up immediately, and then there'll be time at the end for questions too. So that's the plan on this one. What I'm going to do next is, first of all, I'm going to get to what I want to do here. We're going to bring this to the front because that is my presentation. Absolutely. And now I'm going to share my screen. There we go. And pretty soon you're going to see just my basic version right here. And then what we'll do is we'll bring up my slideshow. So in the description of this night, we called it Carnivores and Climate Change. And I added a little bit more here to kind of flesh it out a little bit and also make it very dramatic. So it's losing ground. And it's specifically in Louisiana on the coast. And I'm going to talk about why I'm talking to you about Louisiana when I'm up here in New Hampshire. And this is my doctoral work that I'm doing with Dr. Paul Lieberg in the Lieberg lab at the University of Louisiana at Lafayette. So I was down there to do the research. Once I was done with field work at a certain point, my family and I moved back up here, and I'm still kind of working my way through things. And that right there is an adorable coyote pup that I caught on camera. Now, I'm going to start off by saying I'm a carnivore lover. They're definitely some of my favorite animals. There's no question. I mean, there are a number of reasons. They're cute and cuddly. And they're also, I think, really important when it comes to the ecosystem. And I want to talk about that, you know, at the outset. Why do I think they're important? They do a number of things. Part of it is nutrient cycling. Because they are carnivores and they're eating stuff and then they're pooping, what goes in comes out, and they kind of help keep things moving through a system. And that can be as simple as, you know, a wolf and a deer staying within the same system, but it can also move between land and water. So an otter is a really good example of a carnivore that goes into the water, gets its food, and then comes back on land and poops. And so when it does that, it's actually moving nutrients from place to place. And this can be really, really important in terms of productivity. It can actually boost the ecosystem on land because of the extra nutrients coming from the water. Raccoons will forage on the coastline and whatever they find they eat. So they're also kind of working on that nutrient cycling. We usually think of carnivores as predators, first and foremost. So we talk about prey control, predator control. You know, a basic idea would be the mink eats fish, so there are fewer fish. But we can kind of take it one step further, and we can say the coyote eats nutria, which I'll talk about in a little bit. And so the nutria then can't eat all the vegetation. And now you've got this kind of ripple down through the system. So we call that top-down control right there. There is also predator on predator control too. So this is a picture from the Southwest of some work that I helped with, where a kit fox was killed by a coyote, not because the coyote was hungry, the body was complete, but because the kit fox was competition. And so we see where larger carnivores will kind of control medium and smaller carnivore populations, once again with that top-down control. So they kind of help regulate what's happening in levels underneath them. And then, not at all related to what we're talking about tonight, but actually my favorite part of carnivore ecosystem function is seed dispersal. We think carnivores and meat, and that's what they eat, and that is so wrong most of the time. Carnivores are really omnivores. They eat what they can find. So they eat fruit and other vegetation. They do definitely eat meat. They'll scavenge. They'll go through trash sometimes, depending. So when we talk about seed dispersal, that's actually a big part of what some of them do. And I'll talk a little bit about some of the seeds that I found when I was looking at carnivore diet. But, you know, carnivores also move around a lot. They don't stay in one small space. They tend to have big home ranges. So if they eat the fruit in one spot and then they poop it out in another spot, they actually help that plant get established in new locations. And so this is actually one thing that I really love about carnivores, and I think they don't get credit for it, but it really has very little to do with this. So we're going to keep moving. Now, I'm going to be talking about species that we have definitely up here for the most part in New England, and to be honest, in a lot of places in the United States. Some of them are a little different, but just to give you an idea, so coyotes. They're not native to New England, but they've been here for quite some time now. The same is true of Louisiana. They're not native to Louisiana. Louisiana had red wolves, which were extirpated, and then coyotes moved in. But so, you know, species that we have in both locations, raccoons as well, once again, same species. Otter, specifically river otter, once again, in New England, in Louisiana. And then this is house mice right here, Mus musculus, in both places. The other one I'm throwing in here is the marsh rice rat, which we don't have up in New England. We have other examples. We have of similar rodents up here. So, you know, I'm putting it out there as an example of another rodent. We don't have this exact species, but we have similar species. And the reason that I'm talking about these guys is that we tend to have some assumptions about how they're dealing with climate change, about their ecology, things like that. And I wanted to show you that you can have the same species in two places, and they're dealing with very, very different problems and having to come up with very, very different solutions. So I've got familiar species too, but in a totally different environment, and we'll see that they're responding in different ways. And so that's kind of the goal here when I compare New Hampshire with Louisiana. And so now the climate change part. You know, we hear about this a lot. There are a number of things that we experience. Certainly increased temperatures is something that gets discussed on a regular basis. And certainly one of the poster children for this is the polar bear. We talk about melting ice. We talk about other changes in terms of temperature as well. But we see those, I mean, where we are too, increases in temperature, changing weather patterns. You know, where we have more wet in some places than we used to, or things move through more slowly. Invasive species are a huge issue. This is from New Hampshire Fish and Game. They're doing some removal of an invasive plant species, but we definitely, on my drive to and from work and daycare, I see Japanese knotweed everywhere. So we've got invasive species that are taking advantage of these changing conditions. And we definitely see some species already starting to respond. So here's a graph from Audubon. It goes from 1965 until 2015, and it's a variety of bird species that they were looking at, but they wanted to know, have these ranges of these birds shifted north in that time? And that's what you're looking at. That is the mean or average distance that these species ranges have extended north in the last 50 years. So it gives you an idea that species are responding, changes are happening. We also sometimes talk about changing phenology. And what that means is the timing of things. So you might, depending on where you are, talk about when ice disappears on a lake. Or you might be talking about when, you know, the first frost is happening or something like that. My personal experience, the one that I really pay attention to, is that I'm from New Hampshire. My birthday is at the end of May. I love lilacs. When lilacs were blooming, when I was a kid during my birthday, my mom would cut them and put them on a vase on the table. When I was little, I hoped that the lilacs would bloom in time, because sometimes they wouldn't bloom until June and then they wouldn't be there for my birthday. Now, I hope that they last until my birthday. So in just a few decades, there's already been this real shift in the timing of lilac blooming. And we see that with other plants. We see that with migrations. We see that with all sorts of things. And then finally, sea level rise, which in New Hampshire is not necessarily a big deal. If we're being generous, we've got about 18 miles of coastline, right? And it's a rocky coastline. We're not really noticing. Louisiana is seeing all of these same things: increased temperatures, changing weather patterns. I mean, I watched an inland storm develop that just sat for several days and basically was a hurricane, but it didn't develop out in the Gulf of Mexico or in the Atlantic, and it flooded everything. They have invasive species, which I will talk about, you know, changing ranges, changing timing, and sea level rise is huge. It's so huge that Louisiana has come up with a master plan. Their coastal master plan tries to kind of forecast 50 years out so that they can start planning for how to deal with it. Do they want to do restoration projects? Do they want to move things? Do they want to add things? What I'm showing you right here is a map from that. And just to give you a sense, this is the medium case scenario. They do a range of scenarios, best case, worst case. This is the middle. This is looking 50 years out. If they do nothing, they just let it happen. The red is lost land and the green is gained land. So that gives you a sense right there that climate change is huge in Louisiana, but it's huge in terms of sea level rise. It's big business. There are billions, tens of billions of dollars each year being spent on this stuff. So it's huge, and it's definitely different from what we're experiencing up in New Hampshire. And so we kind of have to think about how species would respond differently because they're dealing with different scenarios up here in the mountains versus there on the coast. So I'm gonna pause for a second and see, Faith, are there any questions?
We do not have any questions currently, Mirka.
Okay.
Except about extirpation.
Okay, so extirpation is when a species doesn't entirely go extinct. So it might still be living in another spot, but from one area it's removed. So red wolves, for example, used to be across a large part of eastern North America. And today you can find red wolves, first of all, in some enclosures in the sense of zoos and things like that, but also in North Carolina, there's a reintroduction program and kind of an area that they're trying to preserve as red wolf habitat. So there are lots of places where there used to be red wolves. Red wolves still exist. They've just been extirpated. They've been removed from all of those other places. And so that's what that means.
And Mirka, we do have one more question hot off the press. Emma wants to know, do we have a greater variety of invasive species in New Hampshire because of climate change?
That's a really good question. So there are a couple, wow. Okay, let me think about the best way to answer this. When we talk about an invasive species, it's not just that it's different. There can be non-native species that show up and maybe they, make it through a couple of generations and then they disappear because it doesn't work for them. Or you can have species that get transported and they do okay in a very specific space and they just kind of do their thing quietly, and we wouldn't necessarily call that invasive because they're not really changing the system. Then you can have what we call invasive species, which are species that come in and they start disrupting because they're able to outcompete. They maybe change conditions because they're taking all the water or the light, that kind of thing. Climate change has definitely, I think, expanded the possibilities for some species that are really good at taking over and have a wide range of tolerances. So we often talk about, specifically with climate change, concerns about diseases. So diseases that might impact trees and shrubs and things like that. There are real, or insect pests that attack plants. There are real concerns that as it gets warmer up in New Hampshire, insects that are causing problems farther south will make their way up. Because now there are better conditions. So climate change has definitely also made it easier for some species so that we do see a wider variety, although we can't totally blame it on climate change because we're really good at moving things around. Stuff ends up in ships that go from one place to another. Stuff ends up sometimes even in your car and you move it from one place to another, or on your boat, for example, as you go from one lake to another. And we're really good at doing that. So we have to take some direct responsibility for moving those species around. Then climate change can make it even easier for those species to establish. There are also just concerns that climate change is a bigger stressor, so it makes it even harder for the species that are dealing with invasives to be able to adapt and cope, because now they're also dealing with changing temperatures or precipitation or something like that. So it can really complicate things and certainly make it easier for some species. There are some that I think about right now that are in the South. Fire ants would be a good example because I hate them and they hurt so much. That I really hope that we never get to the point where up here we've got prime habitat for them, because that would be horrible. But does a warming climate make it more likely that they'll find new places? Absolutely. Anything else?
No, I think that's it, Mirka.
Okay, great. So I've told you why I love carnivores. I've told you about the climate change issue. So now I'm going to talk to you specifically about where I was working in Louisiana and what I was finding. So for those of you who are not familiar with kind of coastal environments, I was looking at barrier beaches. Specifically, these are areas, as the name suggests, with beach, in this case, facing water, like the Gulf or a bay. And they're really important locations for a number of reasons. They provide storm protection. So any wind or waves coming from a big storm like a hurricane has to kind of get past the beach and the marsh before it can get inland. So they're pretty good at kind of lessening that energy. They're really important wildlife habitat. And this is a picture of nesting terns out on one of those islands. And as you can see, there were a ton of them spread out. They love the sand. And so they were nesting, they're colonial nesters. They're all kind of spread out in their space. Barrier beaches are also one of those places where we see those nutrients and energy moving from the water to the land. You know, I mentioned that otters, for example, will move nutrients, raccoons will forage on the beach, and where you've got that wave action, it washes stuff up, which could be fish, dead fish, could be algae, could be a number of things. And that's really important. We call that an allochthonous subsidy. What that means is it's being moved from place to place. And when we have that movement of stuff, it bumps up productivity so much that you can have many more animals living in the same space than you do inland, because there are just so many more resources. And these barrier beaches are really vulnerable to subsidence, meaning the sinking of the land itself, which is a big issue in Louisiana because it's all deltaic sediment, and then sea level rise. Plus you've got storms coming through and they wash them away. So these are vulnerable places, but they're really important. And that lower picture is an example of a restoration project. What they did was they put up like this big tube and they covered it up and held it down with sand and then filled in behind it. And the idea is to keep that beach from washing away because the beach is so important. So, you know, there are a number of different strategies, but these are important locations. We're trying to figure out how to protect them. For those of you who are not as familiar with Louisiana's geography, I want to kind of orient you to where I was. So here's our map. Most people are familiar with New Orleans, which is down in the lower right there. You may not know much else about Louisiana. My study area was down below in several bays there right on the Gulf Coast. So that's kind of within the larger state, and here's a close-up of it. I had 10 sites. Those red stars are my sites that were in 3 bays: Vermilion, Terrebonne, and Barataria. And all of these sites had beach of a sort. All of these sites were facing either bay or Gulf, mostly Gulf. And then these sites were all different. They were different sizes, different distances to places, different levels of human activity. Some places were state parks. Other places, the public was not allowed to go. They might sometimes anyway. And different elevations, different types of plants. Like, they gave me a lot of ways to investigate what was going on there. And this is kind of where that process of figuring out what you're doing. So I knew I wanted to study carnivores. I knew that I wanted something in the United States. I wanted to work in my own backyard and try to deal with an important issue. I knew that climate change was a big deal, land loss was a big deal. What could I build with that? And my advisor said, well, why don't you go out to the islands and just kind of look around for a while? So I tagged along with some bird researchers and went out on a boat with them a couple of times and just kind of walked around, got pooped on a lot. And so I'd be on one island that would have tons of birds on it and no carnivores that I knew of. And then I'd go to another island that didn't have a lot of birds, but had carnivores. And I was like, okay, well, that, you know, makes sense. Maybe the birds are going to the other island because there are no carnivores there. But I also would look out. I mean, look at the place behind me, right? It's mostly water with some shrubs. And honestly, under those shrubs, it's a lot of rock. And I thought, why in the world would you spend your time out here? If you could be someplace else, why would you choose as a carnivore to hang out in this area? What is it that's exciting? Because I don't understand it. And so that was the question. What about these places is appealing? And that's kind of how I started to figure out where I wanted to go with this. So the first thing I needed to do was I needed to find them. Like, you know, carnivores are pretty good at hiding. That's the whole point, is that if you're a predator, you don't want the prey to know that you're there. So they can be very good at eluding detection. So I used a couple of strategies. My personal favorite is the track plate. It is low tech, low cost, and so durable. So it doesn't matter if a big hurricane comes, normally it can handle it. And basically what you have is you've got some sort of plastic plate, and the animal's gonna walk, or could be aluminum too. I've seen it done with several different materials. Animal's gonna walk across it and leave a print. So what I had was plastic, corrugated plastic. Half of it was covered with contact paper, sticky side up. Other half was covered with the powder that comes out of a toner, like a printer toner cartridge. And I put them under the tent, to this little plastic tent here, to protect them from the elements, and animals would walk through and leave me beautiful prints if it worked. So this is a raccoon right here. It works very well for inquisitive animals like raccoons. Also works for rodents, which tend to be smaller. It's not good for big animals. It's not good for animals that are nervous in enclosed spaces. And it can do some funny things every now and then. Like I was going for the prints on the inside, but every now and then I got prints on the outside. This raccoon walked through the mud, then climbed over the track plate tent, never went inside, but still left me beautiful prints, so I knew it was a raccoon. In other interesting situations, the coyote couldn't get inside, so he peed on it, just to point out that this was his track plate. So it still counted like there's a coyote, but not what I was going for. And they're pretty durable, but every now and then pelicans got me, and they would take them apart and then poop all over them. So they're not perfect, but they are great at getting prints from kind of smaller animals, curious animals. I used a smelly bait so that they would go in and kind of investigate. But you need other options if you're going for other animals, bigger ones, for example. So I used camera traps. Camera traps are great because you can set them out, you can leave for a period of time, come back. Any movement in front of it, they'll get a picture, which in coastal Louisiana with lots of vegetation means that any windy day is thousands of pictures of grass doing this that you got to go through, but you do get some great things. This one's a little hard to see, but if you look on the right-hand side, you see those two bright dots. Those are the eyes of the coyote, and then you can kind of make out the shape. So I got some great images of coyotes. Raccoons obliged me and walked right by. In addition to carnivore species, I could get prey, like deer, for example. And then you start getting some interesting things, like people who were in a do not go area, but clearly having a good day fishing. And I also learned that birds, especially brown pelicans, love to take selfies. And if you don't think that's proof enough, this is a few days later, probably a different bird. So camera traps are great for those larger species, those species that don't want to go into something. They can also get you some really interesting images. I have a whole series of images of a soccer ball in the rain, because every time the rain hit it, I think the light made a funny like flicker, and it would take a picture. But they don't work so well for small animals. So if I want really small animals, I need another option, and that was small mammal traps. And so I would put these traps out, leave them overnight, go back in the morning, and then see what I found. Most of the time they were empty. These are not areas where we have tons and tons of rodents running around. Sometimes they had crabs in them. Ghost crabs think that small mammal traps are great for whatever reason. And sometimes I would have these rodent species as well. And so I could then actually figure out what species they were. I could get things like weights. I could tell if they were male or female, information like that. So I could use that information. And this was all systematic, put out the track plates for the same number of days each time, put out the camera traps for the same number of days. But, you know, if you see a track or something that helps you figure out what else is there, you definitely take it. And we call that opportunistic records. So good examples would be these prints right here. The one on the left is a beautiful river otter. The one next to it is a coyote. And then because I was looking at diet, I did actually collect their scat, their poop, and I cleaned it and I went through it. And if I had a coyote scat that had a bunch of, let's say, marsh rice rat hair in it, I knew that even if I hadn't seen evidence of a marsh rice rat moving around, there had to be one in order for that coyote to eat it. So I could use that as evidence too. And so what did I find? Well, a whole bunch of species. I found coyote, raccoon, mink, Otter, domestic dogs and cats, and you might say, hey, those are not really carnivores wandering around. True, except, let's be honest, we definitely know that cats do their own thing, not even necessarily being taken care of. So we've got feral cats out there, and I even watch them hunting in these places. And dogs may be with their owners, but they might not be on a leash, like this nice lab that went by several times on one of my cameras. And they might dig in the sand, they might chase wildlife. So they're still like involved in the system, which is why I included them. A possum, once again, not technically a carnivore, but certainly eating the same things. And if you've ever been faced with a possum teeth, you know that they're quite capable of being aggressive and predatory. I had 3 small rodent species. So the house mice that I showed you, the marsh rice rats, and then also Norway rats as well. And then nutria, which is what this big thing in the middle is. For those of you who don't know what nutria are an invasive species from South America. They were brought up intentionally to be on fur farms, and then they got out. They breed very quickly. Think about like an ROUS, a rodent of unusual size, and that's kind of what we got. Different, nose, but otherwise. They have voracious appetites. And we thought, in general, that they ate grass, and we know for a fact that they eat out the vegetation, and the vegetation will actually start to kind of disappear from areas, and there'll be bare ground, which can erode. But a number of years ago, a researcher put out a camera trap on one of the islands and discovered that the nutria were stealing eggs from seabird nests at night. And then a few years ago, someone put out a different camera trap that could do video and got video of the nutria actually pushing the tern off of the nest in order to get the eggs. So we know that although we might think of these as vegetarians, they're definitely taking advantage of the resources that are out there and acting as carnivores. So we call them ecological carnivores. If you look down on the chart down there, you'll see that I had a wide range of numbers. I had one site that had none at all, and then up to 9 species in other places. So that's what I found in terms of carnivores. I'm going to stop there for a moment and see if there are any questions.
No questions in the box, Mirka.
Okay.
If anyone has any, now would be a great time to type those in, though.
Yeah, and next I'm going to talk about the other stuff that I collected, and then we'll go forward. So I'll pause again after that. So as I said, my question was, why would you be out here? I don't understand it. If I had the choice, I would definitely go to the mainland where it's easier to get around. There are more resources. Why hang out here? And so I figured there had to be a reason. So maybe it has to do with how big the places are. Maybe it has to do with elevation. Maybe it's you can get to them so you're there because they're easy to swim to. Is it because there are people? And that could be like people bringing their dogs on their boat out there, but it also could be somebody, last century built a house out there. They're not there anymore, but at some point mice made it into the house. And so now mice are on the island. It was that part of it. Then there's the beach cast material, the stuff that gets washed up on shore. And that's a picture of one of the fish. And that was a good size fish that washed up right there. Is it because of the food sources like crabs or birds or rodents? Does it have to do with the vegetation? And vegetation is kind of a couple of different ways of looking at it. It could be that you're talking about food sources, right? Fruit or leaves or something like that. But vegetation is also about cover. How much protection does it give you? So when I talk about structure, which I will later on, what I'm talking about is structure is the vertical, is this part of the vegetation. So how much stuff in terms of plant matter is filling in the space between the ground and a meter, for example. Is it easy to see through, or is it so thick that you can't see through it and something could be hiding? So that's what I mean by structure, and we'll kind of look at that. So what I did was I collected information. I counted, it's kind of boring, but I counted crab burrows, and I convinced a number of friends and volunteers to do this same boring work and just walk and count the number of burrows that they saw on a beach and record that number every time they saw one. I counted the number of plant species. I got elevation maps. I did some digital mapping in GIS. I counted the number of people that I saw. I counted and I measured the size of the fish that got washed ashore, that kind of thing, to try to figure out what was there. And then from there, I could figure out why carnivores would want to be there. So before I get to the results, did anyone type anything, Faith?
Let's see. Jean says, why do you think there weren't, oh, oops. Jean, I'm not sure if that was sent to me privately, but I think it's for everyone. Why do you think there weren't any discernible carnivores on Queen Bess Island?
I'm going to talk about that a little bit more, but I think it has to do with a couple of things. It was so much rock. Yes, there was vegetation, but there was so much rock there that unless you were a carnivore who was going to hang out actually in the shrubs, in a storm, you'd have no place to go. It's not like you could really make a burrow for yourself or anything like that. I mean, you'd be absolutely exposed to everything. I think also, at least for some of this, it had to do with it. Queen Bess was really popular. You weren't supposed to go on it necessarily unless you had permission, but boaters would be around there all the time, and I'm sure boaters were going on that island, and the larger carnivores would not have wanted that disturbance. So I think kind of a combination of it being really just wet because it was so much rock and so little soil, plus the people there all the time meant that even though there are all these birds nesting, it wasn't worth the risk. What's interesting is that they're doing a restoration project that's going to raise the elevation of it and bring in more soil. And so I've actually been talking with, I talked with US Fish and Wildlife when they were starting to design that project so that we could figure out like, what's a good elevation for birds that isn't a good elevation for carnivores kind of thing, so that we could like help make the island bigger, but not make it so attractive to carnivores that they want to hang out there. Other questions?
We do. Emma says, counting all the crab burrows sounds like a lot of work. How do scientists calculate population data for larger areas? Can you use imaging, or do you usually need to go to an area in person?
It honestly depends. So if any of you are really interested in some of the different options, there was actually a study that was just released a few days ago that dealt with populations using satellites. And it was specifically looking at emperor penguins in the Antarctic. And what they did was they knew it's really hard to count the penguins themselves, but you can see their poop. And so in the colonies, there are so many of these penguins. And so they could look at the area of the colony and then go to a couple places and say, well, we know that penguins tend to be like this close together when they're huddled. And so a huddle this big means this many penguins. And then they could kind of multiply out to get estimates. So you can do the remote part once you know kind of a bit about your species, your study species, you can do the remote part. In the case of what I was doing, because I knew that some of these beaches were high traffic, I mean, people even drove on some of them. Some of these beaches nobody was paying attention to. I wanted to know the actual number, and you can probably ask any of the people who went with me. This was the most boring thing that any of them, myself included, had to do, because we would walk 100-meter transects, and we would have our GPS, and we would walk until we saw a burrow, and then I had a form, and they'd fill out at 2 meters, there was a burrow, and then they would estimate the distance to the burrow from where they were on the line, and we would just go. And we did that 5 of those transects per location, and we measured that 3 times in the course of 12 months. It was absolutely boring. You know, I'm not gonna lie, I did have my advisor do it one time just so that he knew some of the challenges that I was facing in the field. And so it can be really monotonous in order to do it. Once you know a little bit more about kind of your location or your species, then you can use those remote options, but sometimes the only way to figure it out is to actually go. Other questions?
That's all we've got for now, Mirka.
Okay. So now we're going to talk about what I actually figured out, right? I mean, we did all this work, collected all of this information. What in the world does it mean? So starting off with the number of carnivores, is there a way to figure out kind of what's important? I did something called AIC model selection. What that means is that I'm basically looking at which variables, which things about the environment were important, and trying to figure out how much information they represent. Meaning if a carnivore is in one place but not in another place, and we say that area is important, how much of that difference is represented by area? How much, you know, influence does area have? And so there's a process, this is a statistical analysis that you go through, you calculate, and you start comparing. I'm not going to show you every model. And I'm also just going to point out, I know we've heard an awful lot about models lately in the news. You know, no model is perfect, but some models are useful, as I have been told many times. And so these are helpful in understanding what's going on. If you notice, this is for the total number of carnivore species. The first thing that kind of jumps out is area. Area is important, and that makes sense. Okay, so if I graph that information, the bigger a place, the more carnivore species. Absolutely, because probably a bigger place has more prey types, so you can have more species of carnivore, probably has more resources in terms of, you know, home sites, things like that. But you'll notice there's kind of a line. Once you get close to 2,000 hectares, area is not so important anymore. So there, it's not just area, it's other things too. And it turned out in my sites that it was plant species richness. In locations with more plant species, I found more carnivore species, and it was a beautiful line. I mean, look at that. You really can see how the number of carnivore species goes up. And that once again makes sense to me, because more plant species means, first of all, plant can provide some food, but also plants could be home or resources for prey species. And so once again, if you've got that variety, you probably have many more types of carnivores there to use those resources. So we know area is important. We know plant species richness is important. When it comes to individual species, because I looked at those as well. Coyotes, for example, two big things really jumped out. Number one, distance to nearest landmass, meaning how isolated is it? And basically, if coyotes can swim to it, they'll use the space. You know, they're capable of swimming at least 2 kilometers when they need to, and they certainly can go farther when necessary. So if they can swim to it, they'll use the space, but that's not the only thing. And this comes back to Jean's question. Elevation was huge for coyotes. And it turns out that by the time you get to an elevation of about 3.5 meters, you're practically guaranteed coyotes in these locations. Why? I think there's two things going on here. Number one, I think it's about a refuge in high water. If you've got a hurricane coming in, storm surge is coming up, you better get to high ground. And let's be honest, if you've been to coastal Louisiana, high ground is measured in centimeters sometimes and inches. It's not a huge difference. So you absolutely need that higher space that you can get up above the water at. So I think that's part of it. I think the other part is denning. If you're going to have a litter out there, you need to have a den if you're going to successfully raise those pups. And if you're digging down and you get to the water line, that den is not good. So you need to have that higher elevation for the den. It doesn't need to be the whole island. It just needs to be this one spot so you can get above the water in storms and so you can have a dry den for the pups. I think that's why Queen Bess was not attractive to coyotes, even though it was close to other places. It had a big bird population. There's no way to den in those rocks. There's no way to get above that water. And so I think that's one of the big issues right there. And on one particular island, I know of a pair of coyotes that several years in a row, successfully raised litters. And I think it's because they had access to those things that they needed. I looked at some other species too, raccoons. Raccoons are all about vegetation. And by vegetation, I mean that structure, what's going on up here. And so if we look at kind of structure between 25 centimeters and 100 centimeters off the ground, so up to 1 meter, and then above 1 meter, those were the things that were key, okay? So as we have more stuff in terms of plants happening up here, then we're more likely to have raccoons. And that's not just Louisiana. There are many places where people have found this correlation. Raccoons like to sleep in trees or, you know, big shrubs. They use a lot of those resources. It provides them with protection, you know, cover from larger predators, things like that. So raccoons are paying attention to vegetation, certainly. I looked at otters, and this may surprise you, but the number one thing for otters was actually trees. We might think of otters as going into the water, paying attention to rocky areas, whatever. Nope, It turns out trees, and that's not just in Louisiana. We know not only in the United States, but even in Europe, studies have shown that trees are really important. We think it's because the otters like to kind of curl up in the root area. And so that's why the trees are important. I want to point out, I didn't do water quality. Water quality is a huge thing for otters. You know, if the water quality is bad, so there are no fish, why would the otters be there? But when it comes to land, trees are actually the big deal right there. And finally, I looked at the house mice. And if you look at this, you see that there are so many different things kind of, you know, saying I'm important, but it actually boiled down to just a few things here. First of all, area was important. Once again, I'll get to area in a second. First, we'll do maximum elevation. Maximum elevation, it's the same thing with coyotes, I think. I think it's getting above that high water when there's a storm. I mean, little house mice are tiny. They could easily get washed away. So they need protection from high water. And then area. Once an area is big enough, you're practically guaranteed to have the house mice. I think that is probably because they're good at spreading. I think it's probably also because we're good at transporting them. So we bring them to one place and then maybe there's a storm and they get washed to the new place and that kind of a thing. So that's what I found in terms of what these species were looking for, I felt. The next step is I'm going to connect it to the climate change bit, but I just wanted to stop to see if there were questions.
Yeah, Mirka, Stephen has a question. Do reptile carnivores also play significant roles similar to the mammals?
Yes, in their own systems, absolutely. Where I was working, we would actually occasionally find a reptile carnivore. There were certainly on land and at least one island where we knew that there were snakes, including cottonmouth. So I know that they were absolutely eating those rodents and probably birds and other things as well. I did once find specifically tracks of an alligator at one of my sites. I know that other researchers, even more recently, have actually seen alligators out on some of these islands. So not so much where I was, but in their own systems, like in a swamp, for example, absolutely. The reptilian carnivores and raptors as well. If we can think about birds, you can think about eagles and hawks and owls. They fill a lot of those same roles, these predators. So you can extend it to the oceans as well and think about sharks, you know, and tuna and dolphins and orcas, and then how that kind of changes everything down below them. Other questions?
Yes, one more. Excuse me. Sorry, Mirka.
Mm-hmm.
And what was the most common prey that you found these animals ate?
Wow. Okay, so that is so specific. This is going to be a bit of a long answer, but okay, so I wanted to look at as much dietary information as possible. The challenge is, and this may be too much information for some people, like you really got to be lucky to find poop. It's not that easy. I mean, you might think it is, but you've got to be able to find it. Now, some animals routinely will poop in the same location. River otters, for example, will use a latrine. They'll poop in the same location. That's great, because if you can find one, which is not always easy, but if you can find one, you can get a lot of information. Other animals, like coyotes, will use it to mark territory or along well-used trails. So if you follow the right trail, if you find that trail, you can collect a bunch. Others just do it everywhere. So what I ended up with was I found I've successfully found one otter latrine, which basically told me that otter eat fish, but I think we knew that, right? I didn't have enough from different locations to really assess the otter. I found mink, but not enough to really assess the mink either. But what I can say is that mink eat everything. I was really surprised, actually. I was imagining mink as spending so much time in the water that they would be eating shrimp and crawfish and, you know, fish, things like that. And then I found feathers. I found rodent hair. I found a wide variety. So mink really make the most of their resources. When it came to coyotes, mammals were the biggest, absolutely the biggest. They love mammals, but which mammals kind of depended on where they were. What I found, and this is not just for Louisiana and other places, this has been borne out in the research as well. If rabbits are available, coyotes eat rabbits. They love them. If rabbits are not available, then they'll start to focus on other things. So it really depended. Some of my sites had rabbits, and most of what was coming out of those coyotes was rabbit remains. Other sites didn't, and then I found a lot more in terms of crab remains. Definitely still small mammal, you know, mice or rats, sometimes fish, sometimes birds as well, and insects. Raccoons are really interesting. And I'm going to talk a little bit more about this a little bit later, but I'll be honest, right? We call them trash pandas because we assume that they eat everything. They go through a trash, they'll take whatever's there. And it's true that they can, but they definitely don't. I've collected scat or poop from raccoons that was all one thing, as in so many seeds from blackberries, I think the animal must have gotten sick. Or just completely crab shells. Or a couple of times, and I don't understand this, black mangrove flowers. I have no clue what that one was about at all, and it looked kind of painful. So raccoons can eat everything, but they don't. They actually specialize a lot depending on what's available and where they are, which is kind of interesting because we assume they'll just take whatever it is. In fact, the only animal, the only species that I found that routinely ate stuff from us was the coyotes. And I know it wasn't just like finding something on the beach or whatever, because at one point I found some apple seeds and I was like, well, that's very interesting. Apple seeds, could have come from a core or something like that. And then I found the sticker that had been on the apple. So it was a red delicious. So yeah, coyotes use everything. Raccoons can, but they don't necessarily. Other questions?
Yes, George wants to know how big of an area is needed for coyotes for denning.
The area isn't so important actually, because some of those sites were pretty small. What's much more important is going to be the space in terms, I said, of elevation. So one of those sites, this is going to be a rough estimate, I would tell you was probably about 700 hectares and had a successfully breeding pair over and over again. So they don't need to be gigantic for coyotes, because coyotes are really adaptable to what's available and they'll change depending on the season and stuff like that. For coyotes, it's much more, does it have good denning material like substrate to get into? The other thing is that I personally think that coyotes are one of the most high stress canids there is. And what I mean by that is a fox will see you and like stare at you and then, and then go, or might even just kind of watch you for a while. If there's a loud noise, the fox won't like jump or anything like that. Others, if you think about some others like wolves are very cautious, especially around humans because, they've had bad experiences, but I think they've got a certain level of cool of like, I'm dealing with the situation because I'm a big predator. And coyotes seem to be really high stress. Don't see me. I'm going to hide. I'm going to run away immediately. I am going to do whatever I can to stay as far away from you as possible. So, I was absolutely followed by coyotes at my sites and I never saw them on those particular days. Other times I would see coyotes, but I would walk the beach, come back, and I would see that the coyote had followed me and even stepped in my footprints, and I didn't know it was there. So they're much more interested in not being seen than many of the other carnivores. Other questions?
That looks like all for now.
Okay, so connecting it to the climate change part, right? Because that's what I said this was about. This was partly about the carnivores themselves, but climate change. So we saw that map. Louisiana is going to lose a lot of land. There are in fact a couple of different models. One was developed by the state. It's called LA VegMod. And this is a great model because what it does is it gives you the land area, but it actually tells you the plant species most likely to be there too. So I could actually say how many plant species do we think are in a location. There's also a more generic one called SLAM, which is Sea Level Affects Marsh Model. And that's where I actually had to give it information. I had to say, this is the elevation map. This is the area map. I'm going to set sea level rise at this level, and I made it equal to what was happening in the state version. Now let's see what happens. And so they sound kind of similar, but like they provide totally different things. So here's the state model in 2017 versus the SLAM model in 2017. So that's like my baseline information, and you can already see that they're reading things differently. And I would tell you that the state model is overestimating land and the SLAM model is underestimating land. And that's because the state model says, well, if it's vegetation, it's land. Well, true, but sometimes vegetation is growing in water, right? And the SLAM model doesn't account for the fact that there's lots of sediment coming in and filling in areas still. So I would tell you the truth is somewhere in the middle. And that's true going forward. If we take it 50 years forward, you'll notice, you know, both have lost land. The SLAM model has lost a lot more land because once again, it's not taking into account that there's a lot of sediment coming down the Mississippi. The SLAM model is great because it includes elevation, which is important as we saw for some species. The LA VegMod model is great because it includes plant species, which is wonderful, but neither of them is perfect, but they're helpful. So if we say we've got these models, we know what's important to carnivores, what's going to happen, or what do we think is going to happen? Well, let's start off with number of carnivore species. Area is key. So I'm not going to give you kind of what the specific numbers that are represented here. I'm just going to tell you darker means more species. Okay, so when you look at these maps, the darker areas have more species. If you notice, between 2017 and 2067, we're losing most of it. And that's because the land fragments are getting smaller and smaller and smaller. Do I think it's going to be quite this bad? No, but I still think we're talking about losing those species. They're just going to drop out because there isn't the space. And when there isn't the space, there also isn't the variety of habitat there. When we talk about specific species, coyotes, right, if they can swim to it, they'll go there. Well, once again, if we've got more and more water, fewer and fewer areas. So in this case, the dark is more likely to have coyotes. So once those island fragments get farther and farther away, you know, the chances of a coyote being there get smaller and smaller. It becomes even more of an issue when we add that elevation piece, because then even if we do have something that's big and that the coyotes can get to, if it's not high enough above the water, they can't use it to successfully breed. You know, so what we're looking at is coyotes are going to be disappearing from that system over the next 50 years, unless, you know, unless restoration work is done, unless specific things happen. When we look at other species, different things are occurring. Raccoons love vegetation, whether it's lower vegetation, which is that 25 centimeter to 100 centimeter, or mid-range, you know, which is a meter and above. You don't see a lot of difference here, right? Because the vegetation's still going to be there. Great, that means we got raccoons, right? Raccoons are going to be totally fine. Well, here's the problem. I mentioned that raccoons really like to focus on a particular food when it's available. So I was looking at, you know, crab numbers, for example, and raccoons eat a lot of crabs. So that seemed like it might make a difference. I don't think it does, based on the modeling. What about blackberries? As I said, they eat a lot of blackberries, right? And so we thought, if we think generally, we think about raccoons as being adaptable, they eat whatever. Okay, now I know that they focus. They really eat a lot of this when it's available. They really eat a lot of that when it's available. Okay, so now we know that they're eating specific foods, and that's good. And then that totally went out the window because a colleague went out there with someone else to do bird surveys, and they watched the raccoons eating Portuguese man of war. A bunch had washed ashore, and these raccoons were eating jellyfish. There is no way that I would know that based on the scat, right? Jellyfish don't have those hard pieces. They're gonna make it through the digestive system, come out the other side, and I would know. The same would be true if they were eating mussels, right? They're going to crack it open, take out that soft piece, and they're done. Which means that we honestly don't actually know what these guys are eating out there. We don't know everything that they're depending upon because we didn't have these records. And it's not just Louisiana. Some research was done in Georgia where at the end of it, the researchers said, well, we're a little concerned because anything that's soft-bodied, we wouldn't know about unless we watched the raccoon eat it or we killed the raccoon and emptied its stomach in time to see these things before they were digested. So we can say that raccoons eat a lot of crabs, and here's an example. This one dug up the hole and you can actually see down in the center there, that's a piece of crab, you know, carapace that's been left over. So they'll be fine because there are tons of crabs. But the truth is that we don't actually know what's going to happen because we thought we knew this species, and we got to question a lot of things now. Otters, right? Tree cover. This is what we're expecting to happen to tree cover. So darker means more likely, which means that we're losing those otters. And you might say, well, there's a lot of land there. There's a lot of vegetation, and it's absolutely true. The problem is the trees. So here's a good example from one of my study sites, trees along a waterway. This is a healthy forest right here, not a problem at the moment. The problem is that sea level rise. Sea level rise means salt water is going to get higher and higher. Salt water is going to start intruding, getting into the area with the trees. It's already happened in some areas. And then what happens is the trees die. And so now we've lost, you know, we've still got all the vegetation because there is vegetation that can adapt or is well suited to these salty environments, but the trees for the most part are not. And so as that water table rises, as that salt water comes in, we're going to lose the trees, and that means that the otters don't have this element that they're looking for. And then finally, let's just talk a little bit about the house mice, which is the area bit. And so once again, if we lose that area, we lose them. Now, do I think that people are going to weep tears over house mice disappearing? No. But I think it's really important to just be aware of how they fit in the system. They are food for other animals. They're predators themselves. They do eat grains, but they also eat insects. So we have to kind of think about what that means. If we're losing one level in the ecosystem, there are definitely going to be consequences to that. And so I called this, you know, losing ground. And so we've just seen that there are some challenges out there. Why are they losing ground? Well, I think there are a couple of reasons. In particular with my species, people generally don't care about them. Coyotes and raccoons are seen as pests, right? They get into your garbage, they kill your cat, according to some. I'm not saying that's not true because I can tell you that at least one of the coyotes in my study system ate a cat. But that's not all that they do, and I think we have to look at the larger picture. So they tend not to be the focus of conservation. We think they're adaptable, right? I mean, look at their coyotes in cities. Of course they're going to be fine. But it's very different to adapt to a human solid, you know, environment versus an environment where you're actually losing land and it's becoming wetter and wetter and wetter. Those require different kind of skills and adaptations. And as I said, they're seen as pests. I mean, some of my study animals were even killed during this because coyotes are sometimes a threat to nesting seabirds. So if we want better seabird populations, we, you know, for some, the answer is to get rid of the predators. Do I agree with that? No. Not always. Sometimes, yes. But the automatic tends to be, well, you know, there are tons of coyotes, so it won't matter. Each species responds individually. Right? We saw that coyotes need elevation, but raccoons need vegetation, which means that no one fix is going to hit all of them. If otters need tree cover, but raccoons need shrub, those are different plant dynamics right there. So it's really difficult to just say, well, we'll protect everything. That's too expensive. You've got to be targeted in these environments when you're losing huge amounts of land all the time. So it's like, how do you do that if now we know that they're so individual? But I think it's important to think about this because the whole thing is a puzzle. It's a big system that's really complex. And when we start taking pieces out, without really understanding what's going on, now the puzzle starts to fall apart. And the whole system is at risk, and we lose what we call resilience, which is the ability to deal with challenges. Climate change is a huge challenge, even with all the pieces of the puzzle. When we start taking those pieces out, now it's like a Jenga game, right? You never know which one's going to be the one. Well, sometimes you do know which one's going to be the one that knocks it over, but sometimes you can pull one of those pieces out and that tower is still there, and you're like, oh, maybe it's in better shape. Well, maybe it is, but maybe you just, you know, a little more stress in a certain location and it's gone. And it can be the same thing here. So I think it's really important to understand what we're dealing with before we start saying this is a priority or this isn't important or something like that. So, because this is the system that we're trying to work with right here. This is another one of the examples of the nesting areas. Just in this picture alone, I see at least 4 nesting seabirds here, and a species of seabird, and this isn't even showing you the terns or anything like that. So these are really vibrant places, and they're worth protecting. We just need to know as much as we can while we're making those decisions. And so before we get to any more questions, I just want to thank everyone. Anyone who's ever done work in Louisiana knows that it's really challenging on the coast to get anywhere because the weather is an issue, equipment is an issue, boats, waves, all of those things. So it was really difficult, and I had a lot of help from many, many people to make this all work, and I appreciate it so much. And so now we'll do just kind of any questions that are still remaining and any new ones as well.
So Mirka, we have one in the Q&A box. Are there any trees that can live in salt water? And if not, why can they not adapt?
Okay, are there any what that can live in salt water?
Any trees.
Trees. Okay, so there are some plants that can live in salt water, but trees are a challenge because there are trees that can make it work, but it's really energetically challenging. For example, mangroves. In Louisiana, there are black mangroves. There are other mangrove species that we would find in Florida, for example. Mangroves can handle the salt water. What you'll notice is they've got different strategies for dealing with it. They have to somehow or other deal with the salt. And salt, I mean, in the same way for us, right? Salt is good in a certain amount. We can work with it, but when we get too much, it's a problem. And for trees, plants, salt is a problem. So they have to be able to basically excrete it. So some of them will actually form salt crystals on their leaves. Others will kind of like get all the salt together and like extrude it. But that takes a huge amount of energy. So some plants just think that that's, you know, in terms of development, haven't figured out how to make that make sense for them. It's easier for them to just stay in a more freshwater environment. So trees can do it, but if you look at black mangrove, if you look at a lot of other mangroves, unless they have a good freshwater source too, they don't hit those same, at least in the Gulf Coast area, they don't hit those same like dimensions in terms of size because it is so much work to deal with that salt. Other questions?
Yeah, we have 2, and I'm going to take them in reverse order because one of them sounds like a great concluding question. Okay. So let's start off. Is climate change affecting the health of the carnivores? If so, what is changing in their health?
That's a very good question. I would tell you that I think we would have to say both yes and we don't know in some cases. Certainly if you can't get the food that you need, that's going to have an impact on your fitness, you know, physically. So we definitely know that these are challenging environments, and if they're made more challenging, that can be a real problem. This is also possibly a little too much information for some people, but the one example of cannibalism that I found was a raccoon that had eaten another raccoon out on one of the islands. It was a small raccoon that was eaten, so it may have already been dead. It may have been scavenged. I don't know if it was actively hunted or not, but normally you don't see that kind of behavior unless things are really difficult. So my sense is that these places are, in some cases, you're already kind of on the edge because it is a really challenging environment. If there's more heat stress, less fresh water, that's definitely going to have an impact on health. If the timing of something changes, like those jellyfish, I have no clue if that's a regular occurrence, if it only happens every now and then, in which case, how did they know that they could eat it? If that changes, it's absolutely going to have an impact. I don't think that some of the other impacts that we see up here were such an issue down there. I mean, here, for example, we talk about ticks being a really big problem for animals, for example, moose and other large animals, and ticks getting worse as our winters are milder. Ticks aren't the same issue down there, so I don't think that we would see that same problem for those animals, but certainly other diseases could be a real problem, and that would absolutely impact their health.
And Emma says, well, thank you for putting on this presentation. And then she asks, do you have any suggestions of how people can get involved with conservation efforts in New Hampshire?
Oh, I love that question. That is fantastic. It's almost like I could have asked you to say that. There are some great opportunities. I mean, it really depends on stuff that you're interested in. If you are interested in simply getting outside, there are a number of organizations that will do cleanup of trails or mountains and things like that. So you could definitely get involved with something like that. If you love birds, Audubon is a great way. If you just like going out on your own and looking at birds, then absolutely keep track, and you can submit that information to eBird, which is an online it's a website where you can have an account. You tell them what you saw, how many you saw, and then researchers use the data from so many people over so many years to look at trends. So you're just checking out the birds, but you're helping them figure out what's going on with those populations. If you want to get your hands dirty, there are all sorts of organizations up where I am, because I'm up in Samberton. We have the option of going to the Squam Lakes Association to help out with cleanups and things like that. Down near Keene, there's the Harris Center. There are all sorts of local area groups that are doing things in their backyards to protect green spaces, to figure out what in the world is in their space to begin with, doing surveys. So there's so many ways. And so it really depends on what you're passionate about. If you're interested in animals, then you can find ways to get involved in that part. If you're much more interested in to be honest, in staring at a computer screen, there are crowd-sourced studies where people have 1 million camera trap pictures and they just need someone to tell them whether or not there's something in the picture, because they don't have the time to do it themselves. And you can just be like, no, 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 yes. And you can sit at in your couch and help them do conservation. There are so many ways to get involved. If there's something that's really interesting to you, please contact me and I will do my best to find a good resource and put you in contact with someone. And this goes for anyone. You can find me on the McAuliffe-Shepard Discovery Center's staff page. Just send me an email if you have questions or if there's something that's interesting to you and you want to find out how to get involved, and I will do what I can to connect you with the people who will get you in that direction.
I'm just putting your email address in the box for everyone as well. And I don't see any more questions in the Q&A panel, but if anyone has them, now would be a great time to type them in.
Okay, and I'm gonna stop the share too. There we go. Okay. Thank you guys so much for being here. Really appreciate it. And I just want to point out that this is one of many activities that we've got going to celebrate women in STEM. So there'll be another activity later in this month. Faith and I are still figuring out all the details for that one, but we're pretty excited about it. It's going to be a little bit more connected to engineering, and then we'll do some more things in September. Next week, if you are interested in getting back to the moon, we're actually going to have a Q&A session with Patricia Moore, who's with NASA Outreach. It's on Tuesday at 2 p.m. You can see the information on starhop.com and then register to do it. And basically, she's going to be talking about the Artemis program and answering our questions, which is really exciting. And then beginning of September, we'll have our next Superstellar Friday, and we're still figuring out the details on that one. But we've got a bunch of things happening, so please check out the website. And also, if you have any suggestions, any questions, please send them to us, since we're still figuring out how to do some of these things. Thank you, everyone. Have a great weekend. Enjoy the weather, and I hope you get outside. And I'm just gonna end the meeting. So have a wonderful, wonderful night.
All right, thanks, Mirka.